Right, so we're working density problems, and the first thing we're going to do is put our magic triangle up, right? We remember how to use that. If we're asked to solve for density, cover up the D. Triangle tells us what to do. Mass divided by volume. Solving for mass, cover up the M. Density times volume. Cover up the V. Mass divided by density. So, number 1 asks us to solve for density. A block of aluminum occupies a volume of, so as I read through them, I'm just super OCD about making sure I get the right numbers plugged in the right spot. So I underline my number in unit. Volume of 15 milliliters, and it weighs 40.5 grams. So my formula is going to be mass over volume. When you are plugging in your numbers, you want to include your units. So my mass is reading 40.5 grams. And then my volume, 15.0 milliliters. Right, that looks weird. So then I'm just going to divide that out. So this is what I expect to see on every problem. Even though you can do it in your head, you still have to show work. So I get 2.7. And now when I'm done, I'm going to go back and look at sig figs. This one has how many significant figures? 3. This one has 3 as well. So I need my final answer to be 3. How can I make that be 3 sig figs? Add a 0 at the end, right? Trailing 0 with a decimal counts. And then, oh my goodness, super important, grams per milliliter. Right? So that's why it's super important. If you include the units here, then when you get to your final answer, it's really easy to see what your final unit should be. And then box your answer. So number 2 is a little bit different. Number 2 brings in a little bit of critical thinking. Mercury metal is poured into a grad cylinder that holds exactly 22.5 milliliters. The mercury used to fill the cylinder weighs 306 grams. Calculate the density. So sometimes when you're talking about graduated cylinders, your problem actually might be bringing into the math some displacement, some of that water displacement like you had in your ed puzzle the other day. So just pay attention to that. So here I have 22.5 mils, 306 grams. And so I'm going to plug in. Make sure you're putting in the right spot. 306.0 grams, 22.5 milliliters. So you got to also make sure that you copy the problem correctly, right? That you didn't leave out this 0.0, or then you're messing up on your sig figs. Oh, I messed up. Who's got an answer? 13.6. Is that the calculator answer? Oh, then perfect, right? This one has 4 sig figs, and this one has 3. So I'm going to leave it at 3 grams per milliliter. So number 3 is a little bit different. Number 3 is taking you another way that you can use the formula. What is the weight of the ethyl alcohol that fills a 200.0 mil container? The density of the alcohol is 0.789 grams per mil. So it's giving you volume and density. And when it says weight, that's the same thing as mass. It should say mass. If it was correct, it would say mass. So we're solving for mass. I'm going to go back up to my triangle. If I need to solve for mass, cover up the M. My formula becomes density times volume. So then I'm just going to plug those in. My density is 0.789 grams per mil. My volume is 200. What'd you guys get? Check my math. I got 157.8. So now look back at your sig figs. This one you have to round. This number right here, remember preceders don't count. So this is only 3 sig figs. This one is actually 4 sig figs. So my answer can only have 3. So I just count from the front. 1, 2. This is going to be the one I round. And I look to the right, it's an 8. So it rounds up. So 158. This is where units are important. You're solving for mass. You multiplied grams per milliliter times milliliters. So the milliliters cancels, and you're left with your mass unit, grams. So now number 4 has an added component, and sometimes this happens, where you are given dimensions, but not the volume. So before you can solve for density, you must first calculate solid volume. So that would be length times width times height. And it's giving you those dimensions. That's what I got. So I get this question a lot. If we have 2 problems in one, if you have to calculate volume before you find density, do you have to round in between? Meaning, these numbers are only 2 sig figs each. And if I round this to 2 sig figs, then that 212 is going to change to 210. What do you feel like in the end would be more accurate? Use this number for your density, then round to sig figs, or round this, then do the density? Which one would be more accurate? Wait and do it at the end. Wait and do your rounding at the end. Don't round in between when you have to use this number in another problem, because now you found volume, but you've got to use it in your density calculation. So your density calculation, here's my I hate when it says weighs. It should say mass. At 1,896 grams, and my volume I calculated was that. So if you round in the middle, then it's going to make your final answer less accurate because you rounded in the middle. So you just use the numbers that you've got, then round to sig figs for your very final answer. So when I work that out, 96 divided by 212.52. I get 8.9215. Check me on that. Yeah? Is that what everybody else got? And then let's go back and round. How many sig figs are right here? 4. And this one actually has 5. So my rounded answer needs to have 4. So I count from the front. 1, 2, 3, 4. That's the one I'm going to round. So I'll look right. It's a 5. So 8.922 grams per cubic centimeter. That's more accurate. Okay. So on the back of the worksheet, you have 6 more problems to work on your own, and then you're going to turn this in to me before you leave, and we'll stop. We'll stop there.